Good morning, my dear kids. In today's class, in the circular motion, we'll discuss some numericals on the applications of vertical circular motion. So if you can recollect, we had only the discussion about the theoretical ideas here. Now we'll take the various examples, how we can apply the work point G or the circular motion concepts when the particular particle it is moving in a vertical circular motion. Almost all the theoretical ideas what we know, those things we should apply in the numericals here. Let me start the class. Read the question. A pendulum of length L is suspended at point O. The point of suspension accelerates horizontally with an acceleration A. The minimum velocity that must be imparted to bob at lowest point to complete vertical circular path. Okay, the question is being asked like this. Now look at the point O. We are describing now vertical circular motion about a point where the point is accelerating. Shall we put it in another way? We are describing this in a non-inertial frame of reference. What has to be done? How we should manage here? The idea of critical point will come into picture. That's the only purpose why we are bringing this numerical. The point of suspension accelerates. What the thing is here? The point of suspension, it is the point of suspension accelerates. I think if you look at this part, okay, let's analyze the it is like a theoretical idea than numerical. A student must have the some sort of theory is what we are going to analyze from this given problem. Okay, we'll take the various positions. Some brown color we'll choose. Various positions of the bob. Let me pick up here. Okay, the bob is at various positions. So here first it is here. So what are the forces that are acting? M1G, pseudo force. First of all, what minimum velocity you should impart to the bob at the lowest point so that it will complete vertical circular path. For that, for the bob to complete vertical circle at critical point, it must have velocity greater than or equal to critical velocity. Are you getting now? How to identify critical point? Critical point is one where the velocity of the bob will be minimum. That's all. That is the only thing is. So means now what we should do now? I should apply the work energy theorem from the lowest point to critical point. Where critical point we don't know. That is what we are trying to search here. And what about the critical point where the tension can be minimum? The tension can be 0. Then remaining forces will take care about the circular motion. This is the basic idea of the discussion what we are doing. Okay, let's take the tension here. The tension will be T1. This is having some velocity, the bob. What we have given velocity, this is u. So this cannot be, tension cannot be 0 at point 1. Are you looking at this? Tension cannot be 0. Next we'll analyze here. How the pseudo force will continue to act. It will have velocity v2. What about tension here? Can it become 0? Not possible, no. The string tension must be non-zero here. And what about the critical point where tension can be 0? We have to search that particular point here. So next I'll go for What about here tension? Not possible. Huh? Tension must be non-zero here. Next I have another one. Here MA naught. Because the point of suspension is accelerating. You can see here. No mg. What about tension here? As component of pseudo force will act in the direction, not possible. So here T phi. So there is a possibility, the tension string can be zero and the weight can take it. Okay, we have one more here. So here let's take this theta. Now at this particular point you can see the bob. The resultant of MA naught and MG can act toward this direction, and the tension can be minimum compared to this. Compared to this can be minimum here, or this can be zero also here possible. Now MG. Now the last one. Among them, which can be the critical point? So now see the analysis like this here. The velocity should be minimum. That's all. The velocity of the bob should be minimum. That's the thing. And what is the necessity of critical point? Critical point, how we define? Critical point. The word is the basic definition of critical point. Velocity will be minimum. Velocity of the bob will be minimum, and the tension will be zero. What about tangential acceleration? It can be zero or non-zero. There is no any condition. There is no any condition for tangential acceleration. Just leave it. These two are conditions. Now, if you say that, so this is a critical point, means tension will be zero. What about here? The tension become negative. The tension will become negative. So negative tension not possible in the circular motion, because here the mg can provide required centripetal force. What about here? The resultant of all forces should act towards center. Means ma naught and mg, the resultant of those two should act along this one. You see that only mg is acting. What about here? Only ma naught. What about here? All these are ruled out because mg minus ma naught, the tension cannot be minimum or zero here. Only here it is possible. In simplest way, shall I put it in? The resultant of all the forces should act towards the center so that the tension can be minimum. So this will become a critical point. I'll just show red color. There's just a guess here. So what is the best thing is like we should go for working with a mathematically we should be able to analyze here. So mathematically how to analyze? We'll take the we need a bob rope. No? Yeah. There's a string. There's a bob. We have given speed u. When it arrives here, let it have a speed v. Then there's a point o. The point o is accelerating. We'll define this as theta. What are the forces? Ma naught. The same thing. And the tension, let me call T. Here pseudo force will act and mg. Okay, let's get into the discussion here. If this is theta, this should be theta. This should be theta. I'll call this as the critical point. And the tension will be minimum, so no doubt that one, and it will become zero, that one. So let's write the equations of circular motion. T plus mg cos theta ma naught sin theta equal to mv square L. You can see this, when tension, all these are constant, when tension is zero, then this will become minimum, no? Are you able to get this? Tension cannot be negative, so therefore when t tends to 0, v will become v minimum. Okay, like this is what we are bringing. So what is that theta? Theta is unknown thing. So v minimum, we'll write equation for this. This will become g L cos theta plus a naught sin theta. Keep this equation in hand. Okay, better, yeah. Okay, in the end, we'll substitute here. Let it be V only. Now apply conservation of mechanical energy. I'll apply the work energy theorem between the lowest point and the critical point here. What is the work done? How we write it? Call this as equation 1.
Or A naught L sin theta, sir.
A naught L sin theta. 1 L is missing. Now, initial kinetic energy, work done by tension, work done by weight, work done by pseudo force equal to final kinetic energy. What is initial? This is the initial. This is the final. Let's write here mu square by 2 plus work done by tension 0, work done by mg. So how much of height it will descend? This length will be L cos theta. This is L. So work done by the gravity will be minus mg L plus L cos theta. Work done by pseudo force. This distance is how much? L sin theta. So pseudo force does positive or negative work? It does negative work. Minus ma naught L sin theta equal to mv square by 2. Now this will become u square minus 2gl 1 plus cos theta minus 2a naught L sin theta v square. This is the equation 2. I'll substitute v v square is needed. I'll substitute 1 in 2 so that I'll get expression for u, then we'll see what we can do it here. I think the end answer, you are going to understand this question. Till then the mathematics will work out. Let's solve for u. This u will be 2a naught L 3gl, okay, 3gl cos theta 2gl plus 3gl cos theta plus 3a naught L sin theta. What I should do, differentiate this with respect to theta, you'll get that minimum velocity, then carry on. Now first of all, questions are like why you are putting tension 0? You see this equation, all these are constant. When v will be minimum? When t is 0 only. T negative not possible. What is the least value of tension? Should be 0. then damping. So first of all, now your task question, why you are making tension 0? Because what minimum velocity I should project at the lowest point. So the minimum velocity at lowest point depends on what? The critical velocity at critical point. And when the bob at critical point, what is the critical velocity? The bob will have critical velocity at critical point when tension is 0. Hope everyone is able to understand. The analogy is like this. Don't say highest point, come out of highest point. In the books they have said only highest point. What minimum velocity at lowest point you should project to complete the vertical circle means at critical point the bob must have critical velocity. How you define critical point? Where the velocity will be minimum. When the velocity will be minimum at critical point? When tension is 0. So there is a reason why we are proceeding. Are you getting now? I think this is the idea. Or now we will differentiate this. Differentiating with respect to theta. Du by d theta. I think very lengthy equation. Okay, let me try. This will be 2 and derivative of that quantity 2gl will be a constant, so minus 3gl sine theta plus 3a naught l cos theta. This should be equal to 0. So therefore what do we get? So tan theta equal to a naught by g. Fine. Okay, this angle will get it. Okay, what is sine theta cos theta will define it. Because I have to substitute that one, no? So this is a naught, this is g. That u minimum now will be given by cos theta will be g by sine theta will be a naught by now you do one thing, substitute a naught equal to g. So what is the given? How much will get it? 2gl 3g square l by g. I should substitute everything g, you know. Final a naught square g square, this will be g 6 8gl. Check it once. What is that angle? Angle is equal to theta should be equal to 45 degrees. Okay, this is a minimum velocity, not root 5gl. You see that one. What is telling that? Root 8gl velocity if you give if the point of suspension accelerates. Again, sir, we are not understanding the critical point. What do you mean by critical point? Where the tension in the string will be 0. Now, where the tension can be 0 here, there is a possibility here not possible. Means only here, no, in this region. Here component of tension here not possible, you can see here. So all these region, the critical point not possible. Only these three. Among them, if tension 0 here, it will become negative here. Because as it moves further, the tension decreases. So therefore, here tension at this point can be 0. In this region only it can be 0. Here if tension 0, it will become negative. Means as it moving, tension keeps on decreases. Root 2, huh? Oh, I think I'll.
जी सर.
Oh, I think check it. Okay, G will get cancelled. So I'll do one thing. GL. Okay, now check it. I think this should be our answer. Yeah, I modified it. Huh? This will be our final answer. Now, sir, can you tell the critical point? So critical point means what velocity you should project at lowest point. Who will determine the critical point here? Between what points you should apply Work-Ng theorem or conservation of mechanism, between the initial lowest point where you project and the critical point. How to identify critical point where tension is zero? How to identify that critical point? This is what the mathematics is telling. Where the velocity is minimum. How to calculate that velocity is minimum? This is a formula. Now a student has to make some guess of that one critical point. Where the critical point will be. Critical point will be somewhere here. I'll give several examples. There's one of the case. This is one of the case. I'll give 2-3 examples. You'll get a exact picture.
Sir.
Yeah.
Sir, in the previous class, while doing vertical circular motion, we solved this type of question, sir. There, at highest point, you took tension to be non-zero, sir.
Zero, not non-zero. Zero. Check it.
Okay, sir.
Don't kill the concept. Depends upon the what velocity. No, here something totally different is there. The point of suspension accelerating with what minimum velocity you should project here means I should know critical point. The critical point where the tension will be zero.
Okay, sir.
How to get the tension zero means where you can see the resultant of forces should act means MA naught, the resultant of forces should act towards center. Then tension comes zero. Here not possible. You see, MA naught component of MA naught is not acting. This is one simplest trick to identify critical point. What about here? Component of mg is not acting here. What about here? The component of pseudo force and mg, they're acting away. So tension here will be maximum. Now the same thing. So we will do one thing. If I apply a force, in such a way that just only I'm going to give the different several examples. I'll give it. So it'll be easy for you. So there's a bob. What mean a constantly at all the time a force F will be acting. There's a bob of mass m. What minimum velocity you should project so that it will complete vertical circular path. What is that? At all the positions a constant horizontal force will act here. At all positions. Find u minimum. Okay, now a different situation I brought it directly. So let's analyze this one. See, you have to analyze now. So go for this. Here the bob is there. So what are the forces? So F will be like this, mg. Here it will have velocity v1. What about tension? Will be maximum here. Then when bob is here, the forces F and mg. Tension, I think cannot be zero here. Just keep on draw the diagram. Here F, this mg. The resultant of all forces should act towards center. So now there should be tension. Here also not possible. Then we'll go for next this one. The force F, this mg. where the critical point can be. The resultant of F and mg will act towards the string. So what about here? Mg is acting, the resultant of F is not acting. So the tension can be minimum here. There's a one method is what in the books they're telling. Again, what you should do, you should solve the same method like earlier what we did. Somewhere I assume that one, this angle is theta. Then this will be theta. Then what is the equation we should write? The equation will be, this is T, let this be mg. So how we have to proceed? The similar way, mu square by 2 plus work done by the applied force. What is work done by applied force? So minus FL cos theta, FL sin theta. Work done by gravity, L plus L cos theta equal to mv square, mv v phi square, I'll write it, or v phi equal to v. This is a thing. Then you will write the equation T phi, or let it be same symbol, T phi plus mg cos theta plus f sin theta. Now what is the condition? When this will be minimum, v phi will be minimum when tension is 0. You can see from here, remaining all are constant. So when v phi will be minimum when tension tends to 0. So therefore I'll bring a condition. This I don't know theta. Theta I'm making a guess. This I'll put in 2. I'll go for the differentiation, the same method like what we did earlier. Here in terms of f will come. Okay, let's see the mathematics. What is there in that one? G v phi will be this is 2, no? Just check once. I think mv phi square.
Sir, GL cos theta plus FL sin theta.
Okay, I did know same thing.
Yes, sir.
Yeah. Now the what will happen? We'll solve for u. U will be three FL to 2 will multiply three FL sin theta by m. Okay, this will be 3GL cos 3G anybody just confirm if I'm right. 3 FL sin theta will come.
Sir, that should be F by M L sin theta.
I made no m is there, no denominator.
Sir, no, sir. In previous equation, sir, M by 2 GL cos theta. In that, F by M.
For F it is not there, sir. M.
Yes,
Yes,
sir.
sir.
F
Here
by M.
m should be there. Huh?
Yes, sir.
Here m should not be there. Yeah, m should not be there. Okay, this one m should be there. Huh? Yeah. Now we'll do one thing. We'll rearrange this. 3gl cos theta again differentiating this with respect to theta and equating to 0. I'll differentiate first. Then above 0 minus 3 gl sine theta plus cos theta, equating this to 0. Tan theta is equal to f by mg. So the value of f will determine what should be the value of theta. Okay, now from after this, what you should do, bring the sine theta and cos theta, substitute there, you'll get that u minimum. Please you solve this. I'll go for the next one more. So how to identify critical points? So we should write here now. What is the thing? What all the forces that are acting on the bob, their component must act along the string. This is not a in almost every problem this is noticed here. You can see previously also the component of pseudo force and the weight. Here the applied force and the weight. Component of those, if they act along the string, the tension can be minimum. So this will be critical point. So we should apply now. If at critical point, if the bob is having critical velocity, it will complete the vertical circle. Now, if you project with a speed what happen at critical point, it should have critical velocity. Then it will complete the vertical circle. Critical point need not be always at highest point. That's what previous problem I brought it here. Very first vertical circle motion it was here. Now it is here. So critical point, can it be here? Yes, I can make it here also. We can make it here also. Now instead of applied force, if I apply force in this direction, let it be. Then identify where tension can be 0. If I apply force vertically up, then tension can be 0 here. Here tension will be non-zero. Then the critical point will come here. Okay, this is one basic idea of analyzing this one, vertical circular motions. It's a purely math based one. You should differentiate. How to identify, the best thing is like where the what all forces that are acting on the bob, their components, if they act along the string, there the tension can be minimum, and that is the critical point. That is the reason why I made a guess here. Why not here? You should look at the force. Its component is not acting along the tension, so it cannot be critical point. This is what happened after learning several examples. We are concluding. Otherwise, this is the best mathematically. This is the best way of concluding here. I'll go for the next one. And now, one more example. Like if it is a, there's a bob. We'll take this one. I'll apply force on the bob. All the time the force will be acting vertically up. What is the condition? A force F acts on the bob vertically up at all positions. Find u minimum. What is the condition? At all the times the force will act vertically upon the bob. What is this force from where? External force. Later on in the when we go for the electrostatics, there I'll introduce this force, and that force can be greater than mg, less than mg, what will be that one. Now let's see that. Directly I think there's no question of this be critical point. You can see the F will be acting here. Tension can be there. If tension 0, then whole power required from the nobody is there here, so no question of this. This is not possible. Let's directly go for highest point. At highest point, so what are the forces that are acting? The tension, the force, mg, this is the velocity. Now, can this be critical point? No, not possible, no, because F is there. The string can never be, tension cannot be 0 here. So then where is the critical point? And the lowest point only can be critical point. When it will be? When F greater than mg. F less than mg, we don't have any critical point. When F is, so when F becomes greater than mg, then the lowest point will become critical point. Okay, well, I'll just analyze the cases. This will be, I think, very important conclusion I'm making. If F1, if F greater than mg, where is the point 1? I'll put it. There's a point 2. F greater than mg. In that case, what is the condition? We'll get it here. F greater than mg, then 1 will be critical point. Then what is the equations? We'll write it. We'll write T1, T2. It'll be better. We'll use symbol. What are the equations? We'll write it. T1 plus F minus mg equal to mu square L. Here, if tension 0, U will be minimum. Then when it will be 0? When F is greater than mg. Then what velocity I should project? I think directly it's available from here only. I need not to do anything. What is the critical point? Now 1 will become critical point. Low critical point will be if we just give velocity equal to critical velocity at critical point, it is going to complete the vertical circle. Now I'll make F less than mg. Then we'll write equation T2 plus mg minus F equal to mv2 square by L. If tension 0, then V will become minimum. Tension can be there. Then O will point required centripetal force, the resultant of mg and F. Sorry, this is L. Then you apply this particular thing. So then what we should do? Mu minimum square by 2 is equal to work done by gravity mg into 2L, work done by applied force F into 2L equal to mv minimum square by 2. Substitute this v minimum here, then you get that minimum velocity what you should project here. Now O is a critical point, 2 is a critical point. Are you getting? No, this is. So now that highest point, come out of highest point. Only say critical point. For the bob to complete vertical circle, at critical point it must have critical velocity. Where the critical point can be anywhere, depending upon the situation. Now what is the minimum velocity needed at highest point? You can see at critical point. I'm not bothered highest point. We should not come out of that idea highest point. So what is V minimum? V minimum will be G minus FL by M. GL. Huh? You see that how much it is? Less than the root GL, no? In this case. If F equal to 0, it will become root GL. No, always root GL at highest point? Need not. Always root GL at highest point to complete velocity. It depends upon the conditions given. So usually in the books what happen, only if it's given velocity at highest point it should be root GL. No, there is one of the situation here. So like this, now we have a plenty of this one. Now it all depends upon F. F equal to mg by 4. If F equal to mg by 4, calculate, you'll get some other velocity. And minimum velocity at lowest point will not be root 5 GL, will be some other value. So what you have to do now in all such problems, identify other than tension, weight, any other forces acting on the bob. Based on that, the critical point has to be decided. And if the at critical point, if the bob is having critical velocity, it's going to complete vertical circle. To reach critical point, at critical point, to have critical velocity, you should project with certain minimum velocity at lowest point. In that way, we'll find out. So what is very important now? Critical point or highest point? Critical point here. So come out of that idea of the highest point. So now here, what is the thing? So if you solve this to complete vertical circle, you see this is a very beautiful conclusion we are making here. FL minus GL. What should be the minimum speed of the bob to complete vertical circle? At lowest point, if it is having velocity this much, it is going to complete vertical circle. You need not to bother highest point now. Because at critical velocity, if having at critical point, if the bob is having critical velocity, is going to complete vertical circle. Now for this case, you need not to bother anything about at highest point, sir, what will happen. Leave it. At critical point, the bob is having critical velocity, is going to complete vertical circle. Got it? I just wanted to conclude this thing. In the books, you have only one of the situation, and that is not everything. Now instead of this, one more cases are there. Well,
Sir, in the previous case, if F equal to mg, will it complete vertical circle?
previous case means what?
The previous problem, this one, sir.
192 are there. Which is the previous case? You tell me.
Sir, F equal to mg case, what will happen, sir?
Where, my dear, 1 or 2?
Sir, in both the cases, we can take F equal to mg, sir.
Here, if F equal to mg, tell me what will happen here.
Yes, sir, U minimum will be 0, sir. Like for mg, should be analyzed for another case, sir.
If F equal to here, F is less, if F equal to mg, again you put it here.
Yes,
What is
sir,
the
it will
minimum
become
velocity?
0, sir.
0, that one. So put it 0. Then you have to project with a certain velocity F equal to mg. You see how much you'll get. Root 4 GL is enough. Or check it. Substitute values, huh?
Yes.
There's nothing called like a this or that. What value is there? Substitute here F and work out. With that velocity, you should project here. Now, if here F should be greater than mg, I'm telling. So here, don't make F equal to mg here.
Yes, sir.
Okay.
Yes, sir.
What force you want, substitute, you'll get the values. If you project with a velocity, minimum velocity, you'll complete. Less than minimum velocity, it's not complete. That's all.
Yes, sir.
Now, instead of this, let me bring a rod. Instead of string, let me bring a rod. So this is a rod of what minimum velocity I should project at the lowest point so that it will complete the vertical circle. When the same rod reaches there, even if the velocity is 0, doesn't matter, no, because the rod will take care about that. Even this will be instantaneous rest also. Just non-zero velocity is enough. So is there any minimum something will you put it? Just non-zero velocity is enough, no? The rod after this, the bob is going to swing along with the rod. Okay, able to get this one? So what is the minimum velocity needed means here just non-zero velocity. V must be non-zero. Just V should be okay. I'll do one thing. V must be greater than or equal to 0 to complete circular path. Then where is the critical point? There is no necessity of any critical point. Just at highest point, the bomb should have non-zero velocity. Then we'll apply the conservation of mechanical energy principle, mu square. The tension, the force in the rod will do 0 work. Mg into 12. The gravity does negative work. Finally, mv square by 2. What is the value of v? V equal to 0 also no problem. So we'll get 4gl. So if you project with a velocity root 4gl, it's going to complete vertical circle because it's a rod. I think we have to be very careful. There's nothing called like anything critical velocity, critical point, nothing is there. Just at highest point, the bob should have non-zero velocity to complete vertical, to complete circular path. Now already I put in mathematics, no? At highest point I'll write it. I think the rod and the strings are totally different here. Anybody having doubt, you can clarify.
So, sir, here it depends on the material, sir.
Don't say material, say system. Huh?
Yes, sir.
Steel, copper change. If steel and copper changes, no, don't say material. I think you should say whether it's a string or a rod. Am I right?
Yes, sir. Yes.
Language matters a lot.
Yes.
So that idea of critical point is very important because if I don't discuss critical point, I'll be cheating you. That's all. Your teacher is not teaching anything if he doesn't discuss critical point in vertical circular motion. So this is the most important thing about vertical circle. That's why I had to spend so much of time here. Okay, now rod and string is there. Little bit things are different. That you have to compare it. Okay, let's take the. Yesterday somebody was asked out. Okay, now start reading the question first. This is the smooth hemisphere. I don't know. Yesterday somebody was asked. Mohit. It should complete the vertical circle about 0.2. There's a block. The block is here. I think there's a diagram. The diagram will, the problem will take some other shape if it is like this. Okay, I'll discuss in the end. Read the question. Yesterday, I don't know name. Somebody asked this. The diagram should be very neat like this. Okay, there are 2 points we will take into the picture. One point P1. The other is P2. Theta is given 37 degrees. So let's have a this is the circular track O. For O we are discussing this problem. There's a point P. Yeah. There's a point C. This is O. The block will arrive here with a certain velocity. at point P1. Here, how much of velocity it should have to complete this track? Yeah. Now come for this. Here there's a point P2. What velocity it must have? I think if you can start from here, the velocity of this point, how much it should be? Root 5 gr to complete this circular track. There's a track. Smooth circular track. So to complete this track, the velocity at this particular point should be how much? Root 5 gr. For the velocity to be here, it will have velocity v1. Okay, this will take it x. Sorry, this is r, no? Radius is r. This is r. This is theta. R cos theta. How to get the velocity v1? I think look at this diagram. So here it will have velocity v1. So the block will move from A to point P1. Do we know the radius r? Yes, we know radius r. So applying conservation of mechanicity from point A to P1. Then from P1 to P2. Then we'll get the required answer. And at point P2, how much it should have the velocity? Root 5 gr.
Sir, the OC is smaller, sir, not the radius of smaller track, sir.
OC is smaller, no? Oh. So that OC is equal to R. Yeah, I'll change this. Then we'll assume some other symbol. Radius of this will
R0 will take.
some A will take it. Let A be the radius of that. Okay, I made changes. OC equal to R, that one. What should be the smallest value of? Is asking the minimum value of R so that the block completes its turn about O. We know the total radius capital R. Shall we do one thing? First, we know theta. I want the velocity at V1. Can I apply conservation of mechanism between A and P1? Yes, we can apply it.
Sir, that should be a cos theta.
A cos theta. Symbols, all I change it. Now, one more triangle. Yesterday we are done, no? I remember. Yesterday somebody asked this. P1. Okay, this is theta. So what is the height it will descend? R cos theta. Here it will have velocity v1. It is released from here. No. Carry on, no? Apply conservation of mechanical between point. Okay, this is not needed all. Okay, point P1, this should be the R. So first applying conservation of mechanical energy. So mg R cos theta should be equal to mv1 square by 2. So v1 equal to 2gr cos theta. 2gr. What is cos theta? Cos 37. Anybody value cos 37?
4/5, sir.
Go for this. This is the velocity of the bob at point P1. Now we'll apply conservation of mechanical energy between these two. Then it will be mv1 square by 2 plus mg a minus a cos theta equal to mv2 square. Now we know v2 root 5 ga. Substitute that here. because it has to complete this track, means root 5 GA should be the minimum velocity at the lowest point here. Substitute that V2 root 5 GA from here, V1 substitute from here, then you're going to get A in terms of the required thing. M get cancelled, so V1 square equal to 2GA 1 minus cos theta V2 square. V1 square will be 8 GR by 5. Komal Reddy, mute it. Just get on. Anybody value? We'll get A. From A we can get the OC. OC should be equal to R minus C. The problem will change if it is like this. If it gives track like this, the problem will change. If it gives track like this, no? I think we have to be very careful enough. Directly at this particular point, if the bob is having root 5 GR, root 5 GA, whatever that is there, no? I think it will complete vertical circular path. Because it has to complete the loop here. So what is the velocity at this point? Should be equal to root 5G. What is the radius of this? Let it be A. Because this will be the lowest point of the track. Now the track is something like this. P2 is not this one. You can see that one here. I think you have to be very careful about how the small track is. Anybody value?
Sir, small a equal to 8 and small r equal to 15, sir.
OC value?
Sir, OC value is 15, sir.
15, 15 centimeter, 15 meter. I think problem will become different this one. Are you getting no? How that track is brought here? Huh? Just be careful. I'll remove this again. This is one very important one. I think this also somebody asked yesterday.
One scroll up, sir.
Very fast, huh? I'm going to send PDF, no?
Waiting, sir. That's why.
Now, this is a pendulum. I'm going to release this from rest with the string horizontal. Find the net acceleration of the bob when it is directed vertically up, down and horizontal. Okay, the moment I release, here what are the things? Okay, this will be straight here, the string will be straight. So the weight of the bob will act here. So this will call 0.1. So what is the acceleration here? A1. So how A1 will be directed? Vertically down at 0.1. Next, when the string becomes horizontal, vertical, when the string becomes vertical, it will acquire, let me call this as a 0.2. This is a string. Then here mg, tension T2, you write it. How to calculate this speed V2? All acceleration, it will be, the resultant acceleration will be about vertically up it will be. Then V2 equal to root 2 GL. Applying convention of mechanical energy. Then what is A2 equal to V2 square by L. And how it will be directed? Vertically up. So at the moment you release, the acceleration of the bob will be vertically down. At lowest point, it is going to describe a circular path like this. At lowest point, how it will be? The acceleration will be, the net acceleration will be directed vertically up. And how much it is equal to 2g. And how much a1? A1 must be equal to, now is there any point in its path where the acceleration, total acceleration will be horizontal? We are trying to search. Is it possible or not? We don't know. That is what we are trying to search here. So let's pick up a point now. I'll choose somewhere here. So let this be the bob. No. What are the? It will have some velocity v. Let the tension, the string, let it be t. The weight mg will act here. Let the string make an angle theta with the vertical. Now what are the accelerations? There are accelerations will be, let me call this a point 3. A tangential and a normal. These are the accelerations will be there. A tangential, a normal. We'll just write it here. What is a tangential? Should be g sine theta. What about a normal? V square by L. And the resultant of these two should be such that it should be, the total acceleration should be horizontally stilling as possible here. So here we'll take a rough diagram. If this is a string, a tangential like this, this is a normal. Call this is theta. This will be theta. Now when it will be, total acceleration of the bob will be horizontal only when the vertical components of this a normal and a tangential are equal and opposite. If they are equal, an cos theta, if it is equal to at sin theta, then the resultant along x-axis will get added up and the net acceleration of the bob will be horizontal. He is asking how much is that acceleration and where it will happen. Okay, let's apply the conservation of mechanical energy here. Now what is the height it will descend? L cos theta. So mg L cos theta should be equal to mv square by 2. So v is equal to 2gl cos theta. Then we'll calculate a normal. A normal is v square by L. So this should be 2g cos theta. What about a tangential? A tangential should be just g sin theta. Resolve g. Component of g will act here. G sin theta, g cos. A normal should be v square by L. Already we have discussed everything in kinematics. Directly I'm writing it. Or else what you should do? T minus mg cos theta equal to ma, and then you should calculate the tension, other things. Not needed, no? Directly get into this one. Centripetal acceleration depends on what? Square of tangential speed by the radius. L will be the radius of this path. Now, what is the condition? Along an cos theta minus at sin theta must be 0 because the total acceleration should be horizontal, no? Therefore, vertical components should cancel out. So this will be 2g cos theta into cos theta. At is g sin theta. So theta equal to tan inverse of 2. At this particular position, the total acceleration when the string makes an angle tan inverse of theta, tan inverse of 2, the total acceleration of the bob will be horizontal. Can we calculate how much that? For that I should add up an sin theta, at cos theta. an equal to 2g. Tan theta equal to 2 means go for a triangle. This should be root 5. So let's substitute all this one. An will be 2g cos theta sin theta. A tangential will be g sin theta cos theta. This will become 3g sin theta will be 2 by root 5. Cos theta 1 by root 5. 6g by 5. And how it will be directed? Horizontal. Very simple. It's there in material. I don't know how many of you made really observation. The total acceleration can be directed with the moment you release the bob, the total acceleration is directed vertically down, here horizontal, here vertically up, here horizontal. Tan theta root 2.
Yes, sir.
Yes, sir.
Oh, in hurry I mean, I'll make changes then. Then this will be root 2. Root 3 this will be?
Yes, sir.
Yeah, okay, fine. 2 by sine theta will be root of 2 by 3. Check it. G root 2. Yeah, Vishal, thank you for correction. Check calculation once. It will be directed horizontal. Vertical circular motion, shall I say it's unlimited. You have to just keep on take the different cases here. But everywhere what will happen, already we know dynamics of circular motion. Then we are going to use Work-Ng theorem. Rest all you can manage. I'll slide down. You see, it's some very simple. Just read question carefully. Light rod. He himself is telling there's a light rod. We'll bring a light rod. And keeping the other end of the rod fixed, the minimum speed of point when the light rod is horizontal. Somewhere here. I need not to project from vertical position. I can project from here also. There's a rod. Intentionally not given diagram is asking what is this minimum velocity so that it will complete the circle. Then what should be the minimum velocity should possess as there's a rod? And there's a rod. Just non-zero velocity is enough, no, here. Even if it's just non-zero, just I'm saying just non-zero velocity is enough. So somehow if this bob can reach the highest point, I think problem solved. So you do one thing, write V. No. V greater than or equal to 0. mu square by 2 minus mgl equal to mv square by 2. When v is equal to 0, u will become minimum. You can project the bob from wherever you want. It's not always it should be lowest point. I think that's what he mean to say. Moreover, rod is there, so don't try to root GL. So root GL at highest point. No, it's a rod. No need of anybody. The rod will take care that the bob will complete circular path here. Sting rod comes, you have to be alert. I can project it from here also. It's not that lowest point is preferred because there is an equilibrium point, no? Because here you have to hold it, release, the moment you release again you should project. So that's why in the books maximum numericals are with bob at lowest point only. To trouble you like this, we'll bring some questions in exam. Objective questions, you have to be very careful. I'll scroll down.
1 second, sir.
You look at this. We have this situation on an inclined plane. How to manage condition like this? So I think we should do now this problem in the plane of incline. The yellow color is the plane of incline. We should discuss this problem in the plane of incline. Then what was the acceleration of the bob, component of gravity along the incline? G sine 30. In place of G, it will become G sine 30. In place of that, G sine 30 will come. I'll try to explain through diagram. So here it is going to move in a what minimum velocity it should be projected along the incline, this one. So look at now here, you take help of the, this will be G. So if you resolve G sine theta, G cos theta will not have any role. What all will be there will be G sine theta only. So instead of G now, G sine theta will come into picture. Mg sine theta will act here. So here I think if you can make careful observation, if there's a bob and there's a string, and the O is a point of suspension. Take like this. Here what are the forces that will be acting? Mg sine 30. The tension. Then at highest point, it's a critical point. Then what are the I'll write T1, it is better. T2 mg sin theta. So again the same analysis now, instead of G now G sin theta has come into picture. That's all, nothing is there. T2 plus, we'll write it here, T2 plus mg sin theta equal to mv square L. L is the length of the bomb. Then if tension is 0, then V will become minimum. Then apply conservation of mechanical energy. Mu square by 2 minus mg L to L equal to mv square by 2. When V is minimum, when V becomes V minimum, U becomes U minimum. Solve this now. I think only instead of G now, G sin theta has come. Most troublesome students will start thinking something big. So after solving this, the same vertical circular motion we are analyzing on an inclined plane. See, you have to pick up now. Really, if you want a vertical circular motion, just go there and start analyzing the different situations, cases, what the conditions are there. Because on one side you know dynamics of circular motion, the other side what you know, the work energy theorem or conservation of mechanical energy. The two things parallelly you should apply. Always have a diagram, show that at various points, and always as it is a search for critical point. No, definitely, sir, is it a critical point? Yes, there is a critical point. I don't want to use word highest point here. So come out of idea highest point. At critical point, if the bob is having critical velocity, it will complete circular path. What is this? This is the critical velocity. So try to avoid using highest point. Always say critical point. At critical point, the bob should have critical velocity to complete the circle. I'll scroll down. Very good problem to test you. Let's see that how you manage. If the alpha gives the angle between the radius vector of either ball with upper vertical, find the condition for which the tube bounces up the table. So it's nothing but it's asking now. It will bounce up. Why do it will bounce up? The vertical tube, I'll bring it. Very difficult. I'll try. Okay, my vertical tube got over. There are two balls are there. I'm going to release them. They can slide. Slightly the diameter of the ball will be less than the width of the tube. Radius of this. This is R. So mass of the balls, mass of the tube is M, mass of the balls is small m. There's a ground. It is placed on the ground. I think I give a better diagram. Okay, look at this and start analyzing now. Let me help you. It's telling as they slide at one specific angle alpha, it is going to bounce up. Alpha is given. Then is asking find the ratio of, find the conditions. Means how capital M and small m are related. I will, okay, capital M and small m. Hurry up now. Why do it will bounce up? Okay, let's study the motion of this particular balls that one. So when they are moving inside that, how do they move? Go back to the first vertical circular motion, first problem. As the person sliding on the hemisphere or the bob, it will lose contact, no? And what is that angle? Cos theta equal 2/3. Can you remember? The very first problem, vertical circular motion we have started. It cos theta equal 2/3 to lose contact. Either the same thing, no? So like on a bob of mass m placed on hemisphere, if you can recollect. After certain sliding some distance, it will lose contact. And what is this? Cos theta equal to 2/3. Can you remember this? Now it's telling like there is certain angle theta at which it is going to lose contact. Then is asking what is the conditions for that? How that mass of the ball and mass of the tube are related. Very least information is given for us. With this we should manage. And now come back to this one. At the bob slides, it will lose contact. It lose contact means here it will not be, it will fall parabolic path. Now the same thing happens. This particular ball will sliding. So now the tube is now will come this one as it slides. Tell me like somewhere at an angle cos theta equal 2/3, it is going to lose contact from this inner wall, no, of the tube. What is a tube? This is a tube. This is the inner wall. this outer wall. It will lose contact as these two slides, they lose contact from the inner wall. When they lose contact, they want to fly off. What this outer wall will not permit. So definitely these balls, what will happen now, will come in contact with the outer wall. No, they'll exert a force. That normal contact now can lift this particular tube. Hope everyone is able to understand now. So what will happen to the bob? Till cos theta. So that alpha is telling. Okay, we'll take that alpha here. Here we'll make alpha. Just what you studied is asking you to apply here. What you studied here, you have to apply it. Okay, let me. So many diagrams. Already there I indicated. Now come for this one. So these balls, when they are here, you see how I'm showing it, they are in contact with the outer wall. This what is alpha. Now the normal contact on the tube will be like this. Okay, they will have velocity. When they are about to leave, they will have tangential velocity. The normal contact on the tube will be like this. On the ball, you have to show in this direction. Make observation on the tube, on the ball. Now the weight mg is acting. Look at this. Now if this is alpha, can we take this is alpha? When do the tube will lose contact? When n 2n cos alpha is equal to mg, it will lose contact. Is it okay? Okay, let's get into the calculation. I think I'll take out this diagram, not needed. We need some space now. Let's get into the concept. This is initially the release from rest. Tube is about to lose contact. Tube about to bounce. So when it will bounce up? When 2n cos alpha greater than or equal to mg. Okay, then what to write that n? What is the equation for n? What is the equation for n we can write? Look at only the bob. Now what are the forces acting on the ball, that one? We'll have small diagram. So if this is alpha, this should be alpha. mg, this is n, mg cos alpha, and this is the velocity. Okay. Now we'll write the equation of circular motion. Mg cos alpha plus n should be equal to mv square by r. But we don't know v, what to do? Because we need n. For that n we need v. How to bring v? So what is the height it will descend? How much of height it will descend? R minus r cos alpha. What is v square? V square will be 2gr 1 minus cos alpha. Let me substitute v square value there. Mg cos alpha n is equal to 2gr 1 minus cos alpha by r. mg cos alpha n r will get cancelled, so 2g 1 minus cos alpha, so n should be equal to, m is missing, no, here, m is, n should be equal to 2mg minus 3mg cos alpha. This value of n I'm going to substitute there. This is the equation 1, 2. Put 2 in 1. Then three mg cos alpha greater than or equal to mg. Small m this is. Now g will get cancelled, so this will be 4 anything cos alpha can we write it as? Cos alpha is given for us, no? So the ratio of small m by capital M. Four minus 6. Okay, if this condition is satisfied, it is going to leave the tube is going to bounce up. Any reason what makes the tube to bounce up? Because as the ball is sliding, it will lose contact here. It will go and strike this particular thing, outer wall. The normal contact will act. This normal contact now, if it is greater than the weight of the tube, and the tube is going to bounce up. Then for that we have brought it here. The application what we did there is being asked here in different way. I'll scroll down, make observation. Completed? Let's take the next one. Yeah. This is some purely diagram based question. Let's see that. Read the question. You have to read the question. Now they are released from same height. I think I can get the diagram. Look at this one now. So here the release from same height. The dot is what a block. I'll just make it. The block when the release. So it will arrive here. The minimum height of Q above the ground. So here I'll release it. This height will take it HP. This height, let it be HQ. Look at this one now, HP and HQ. Now at this particular point, what is the necessity? The bob should have the velocity, so let me call that as V1. Here also the bob should have velocity at highest point to complete vertical circular path, let it be V2. I think clear, no problem everyone. So what is V1? Now R is the radius of this one. Look at this, it's elliptical. Radius of curvature, center of curvature of this will be here. What about this? Will be less, no? I have to draw the radius of curvature of this is equal to this much. R1 you write. What about radius of curvature of this? Should be less, no? Here, elliptical. So if I draw a circle, able to notice this one. Now where is the center of curvature? Center of curvature of this will come here. Now this will become radius. Able to see this? I think I can better explain like this. This is R2. Now here it will have velocity V2. This is not center of curvature. Are you getting? No? Center of curvature will come here. So what do you expect this R2? Less than R1? Are you seeing this? Because this ellipse, no? Its center of curvature will be here. For a circle it will be here. I think it's a pure diagram based question, nothing to do this one. So here R2 is what? Less than R1. Then what is the minimum velocity to complete circular path here? Root GR1, root GR2. Agreed? Then at lowest point, what is the velocity it is needed? U1. Here you call U2. Now we know U1 should be equal to how much? Root 5 GR1. What about U2? Root 5 GR2. R2 less than R1. So what do we expect? V2 less than V1. U2 less than U1. Then the U1 depends on what? U1 depends upon root of 2 GHP. U2 depends upon root of 2 GHQ. As U2 less than U1, so what do we expect? HQ less than HP. The condition is he has asked like this. That ellipse idea must be there with the student, the center of curvature. So definitely HQ should be less than HP is telling. No need of any maths, just by observation you are supposed to crack this question. Two particles are connected by a rigid rod. of negligible mass and slide with negligible friction in circular path of radius 10 meter. Inside the vertical circular ring, if the system is released from rest at theta equal to 0. It's something simple. You start getting confused. Okay, this is a ring, will take it. We know to draw complete that one. So initially how it is like a theta equals 0, mass m and 2m is there. So we'll have a rod. All these are diagram based questions. Making observation of diagram is essential. It is like this. Now where is the rod? Let me bring the rod. Keep it rod like this. Now finally the rod has become horizontal. Release theta equal to 0 is telling. So here the bob, they should be in contact with the inner wall. Yeah. This is the position in which they are released. You see, no? What will happen to them? Let this be radius r, radius r. We know this length L. Now also it will be length. It will be symmetrically about this particular point. This is 2m, this is m. They are released from rest. Now when they arrive, so here this will have a speed v. This will have a speed v. They should have a same speed or different speed. First primary question. Anybody wants to answer?
Same speed.
Because the rod, no, the length of the rod should not increase or decrease. The velocity of the ends along the rod must be equal. So therefore they must have same speed. We'll take this as, say, some angle phi. He's asking only that speed v. So this should be the 2m. This should be the m. How to calculate that speed? Decrease in potential energy of this particle 2m should be equal to increase in potential energy of this particle m plus kinetic energy of these two bobs. How much potential energy of this will decrease? So we have took this angle as phi. This is r. So this should be r cos phi. So what is the height it will descend? R cos phi. This height is r cos phi, no? Because this is r. So what is this height now? R cos phi. Then it has ascended height. How much? R minus r cos phi. Call h. So what is h? Should be equal to r minus r cos phi. Now we'll write down the equations. Decrease in potential energy. 2mg r cos phi should be equal to increase in gravitational potential energy of the other bob. mg h plus mv square by 2 . What is h? H is r minus r cos phi equal to, this will be 3m v square by 2. M get cancels. So this will be 2gr cos phi equal to gr 1 minus cos phi 3 by 2 v square. We don't know phi. What to do with phi? Anybody answers? How to bring the phi? L by 2, L by 2. What is cos? What is sine phi? L by 2 by L. And what is length L should be equal to? R root 2. Check it now. L by 2R. This should be equal to R root 2 by 2R. 1 by root 2. So phi will be 45 degrees. That will substitute here. 2G R. Intentionally they are not given that length of the rod. From the diagram we are supposed to calculate. Solving this will get the required answer. Okay. Nothing to do. Conservation of mechanical engineering. Sir, I want to write some normal contact. How much is there? Yes, go. Come on, right now. Who is stopping you? So there's a normal reaction. Call N2. What is the normal contact? N2 minus 2mg cos phi equal to mv square r. N1 minus mg cos phi. They will have same normal contact. Check it. N1 and N2. They may ask you all these things. Find the normal contact, everything. Or they'll ask you find the tangential acceleration, centripetal acceleration of the particles here. Is it okay this, or anybody wants to say, sir, how it is possible? I want students to make observation. Intentionally I brought this. Is it agreed this, or anybody wants to object? Anybody wants to object this? What makes this particle to move? The rod only, no? So continuously this rod will be pushing it. Continuously this rod will be pushing it. This rod will be trying to oppose. So there's also reaction force in the rod. Then how come you apply conservation of mechanical energy, sir? We don't agree with this. This should have been the question from your side. The net work done by the reaction force in the net work done by the force set up in the rod. Okay, there's some force will act here, no? Because you see that one. The weight of this will act along the rod. So the rod will push this particular bob, then only it is able to slide up, no, otherwise how it will move. So therefore there will be some force is set up in the rod. Don't call tension, because the tension is set up in the string. In the rod we should not call tension set up in the rod. Force set up in the rod we should not call tension. To make you understand, let me call tension. A tension is set up in the rod. The tension, what happen, will push the block. So then work done by tension should be there. Net work done by tension in fact will be 0. There is a reason why I am able to apply conservation of mechanics. What about normal contact? Normal contact will always act perpendicular to displacement. So therefore what is the conclusion here? Work done by normal contact work done by tension also 0. What is T? T is the force set up in the rod. I think we have to be very careful here. Huh? What is the T? T is the force set up in the rod. What is the work done by this force? Will be 0. So now at this particular point we have to show that also here it is acting like this. Now I think things will change. Will you make any changes here? Component of tension should also act here, no? This will be fine. This will be this will be fine. T sine phi will come. Very important in exams. Definitely, they will trouble you with all these things. Huh? You have to be very careful. N2 should be 2m, no? Yeah. You have to be extra alert. Write it down. I'll slide down. String, like a force set up in the string, tension it is called as. Force set up in the rod is called as a, we should not call tension, we just say some sort of reaction in the rod, or force set up in the rod, we'll see. That's why I didn't try the tension. One more very simple problem. Let's see that how you think on it.
Sir, can you zoom the question a little bit, sir?
Zooming. Happy now?
Thank you, sir.
Just reach at point A. All these are objective level questions will be asked for you. Small thinking. This is the initial portion. You should just reach there, no? We'll see here now. Okay, the block is here. Just reach means what shall I do? So what makes it to slide up? Now shall we discuss the problem with respect to here? So let there be a person. We'll ask him to solve. So that'll be easy for us. This is what happened. It is accelerating. No. We'll ask this person to solve. What makes the block to reach A? Who is there? The pseudo force. Here the pseudo force will act here. What are the other forces acting? mg, normal contact. This pseudo force will accelerate it. So when it is here, you can see now clearly. Just reach is telling it will have velocity. This is the normal contact. Okay, this component of pseudo force does work, and the weight component of weight does work. So what will happen? It will start sliding up. Somehow what will happen is telling like it should just reach there. Start it from rest, and again it will come to rest here. What about the work done by normal contact? Should be 0. Then all does work, the weight and this one. So shall I apply conservation of mechanical energy? Anybody wants to answer? Pseudo force is not a conservative force, no? So therefore we'll go for work energy theorem. From that, Kd plus work done by normal contact, work done by weight, work done by pseudo force equal to final kinetic energy. It is at rest, work done by normal contact 0, because normal contact always acts perpendicular to velocity. So therefore work done by normal contact must be 0. Work done by mg into just reach. Okay, let it be r. Radius is r, will take it. What is work done by pseudo force? It does positive work. That's all, no? Objective questions, very uh, you have to put effort here, because sir, root 5 gr formula I'll apply, complete minimum velocity to complete circular path. Put that in dustbin, how it is related here. So what students are thinking, vertical circular motion lowest point root 5 gr, 5 gl, highest point root gl. It need not always. That one of the case, that vertical circular motion is one of the numerical it is, that's all. Sir, if I make acceleration more than g, at a it will have velocity. No, sir, what acceleration I should give so that it will complete the vertical circle? Yes, we can make it, no? At this particular point, how much of velocity it should have now? Root gr. So then the pseudo force work, what it should do, by the time it comes here, the net work done by it should be increase in gravitational potential G plus it should have kinetic energy. That much of work is what the pseudo force should do. Make observation of all small numericals of this kind are very essential for student to analyze. One more last, we'll wind up this. A very beautiful question. It's there in laws of motion chapter. That's why I didn't give. Now let's work out here. It is going to oscillate the minimum coefficient of friction between the mass m and the horizontal. You see that? There's a block. This will be at rest. Is executing that one. So now when it comes to this position, when the bob it is going to swing like this, no? This angle is given 60 degrees. When it arrives here, this bob, how much of velocity it will have v, the tension here, right, t, length of the string is l, how much of height it will descend, h. So decrease in potential g, mg h should be equal to mv square. So v equal to root of 2gh. What is h equal to? H must be equal to L minus L cos 60 degree. So L minus L by 2. I'll get the velocity now. Root GL. Let's write the circular motion equation. T minus mg equal to mv square by L. Here you have to look at this. I'll give some color. There's a bob. Okay. Let's analyze. So this is going to oscillate. The tension is there. Now this tension will act. This tension, what one will try to pull, no, the block is not moving, means there should be limiting friction should act here. So do we know, okay, what is other this T, what is V equal to? mgl by L. T equal to 2 mg. Then I'll write the equation T minus mu 4 mg. Equating these two. Okay, mu equal to 1 by 2, we'll get it. So what actually happening as this where do this block is about to slide, when this bob is at extreme or when the bob is at lowest point, where the tension will be maximum? When the string is vertical, the tension will be maximum. Then it can shift it, no? So you should not equate here. Some students, what they do, they'll try to equate this. Sir, I'll do like this. T1 minus mg cos 60. Why can't you equate this T1 here mu 4 mg?
That is not maximum tension.
The tension will be maximum here, no? The T will be greater than T1. Tension will be maximum when the string becomes vertical here. Something different types of numericals will be asked for you. You have to search numericals of these kind. Plenty of good numericals are there in almost all books what you have. Pick up questions of different kinds where vertical circular motion linked with some other ideas. We'll end up the class, yeah. Okay, kids, like we had the discussion about the application numericals on the vertical circular motion. So you have seen the different types of questions what I brought it here. Idea of vertical circular motion have in mind, then it can be mixed with some other concept. These are the types of numericals is what you should practice it so that you get exact picture. Okay, well, end up the class. Thank you all of you.